Okay, so the first thing that we wanted to make sure that we could do, and we'll need to do this several more times during the course of the year, so I want us to have a procedure that you can go back to and say, this is how I do this. This is how I find the mass of a reactant. Okay, this is how I find the mass of a reactant. And so we are starting with step 3. You don't need to put a little circle around your steps. So determining the mass of each reactant to use to make each solution. What's the first thing I do when I try to figure this out? Yeah, Aspen.
Studying the amounts into the formula.
Okay, so how would I say that? What's the first formula that I talk about? I'm sorry, I can't hear you. Oh,
sorry. You need to know the amount of moles you need, molarity.
Okay, well, what formula do you write out first?
The grams.
So,
Yeah.
write out gram formula. Grams equals moles times molar mass. Okay, a lot of you, and I was this way as well, unless somebody explicitly said, do this, I wouldn't know how to start doing this, right? So write out the gram formula. This is what we're talking about here by a procedure. Write out the gram formula. Inspect formula to see if you have all information. Inspect the formula to see if you have all the information. What if I don't have moles? What do I do next?
Do the formula for mole.
Okay. Write out mole formula. Moles equals molarity times liters. Again, if you're like me, unless somebody explicitly said, do this, do this, do this, even though somebody's shown me how to do it 1,000 times, I don't remember how to do this. Okay, so what we want is something you can go back to, and when I say, this is your first thing, how do I do this? You can go back to this and say, this is how I do it. Right? Add given data and calculate the moles. Okay? Maybe I'll give you the molar mass, maybe I won't. That. I don't know why it's been doing that to me. still thinks I'm connected. It just feels compelled to shut off. It's ready for break 2. Okay, so determine molar mass. And then plug information into gram formula and calculate. Okay? Does this make sense? It's a step-by-step procedure, and you know, a year from now or 4 years from now, you'll think, man, that was the most micromanaged, intensely written procedure to do something so simple as this that you can think of. But again, unless we get into the habit of listing out all these steps, we're going to forget stuff, and we will not correctly accomplish what we need to accomplish. Write out the gram formula, inspect it to see if you have all the information, write out the mole formula, add given data and calculate moles, determine molar mass, plug information into gram formula and calculate. Now, if I were to do this again next week, which I will with the other group, do you think my set of 6 steps here for this part of the procedure will be exactly the same as what I've written out here for you? It's not, is it? It's not going to be exactly the same. And that's okay, right? One of the things that a lot of people get bent out of shape about when they're trying to start to do something like this is I've got to say it exactly the way Marshall wants it said, or I've got to do this exactly the way that that a scientist would say this. All we're doing is saying you're telling the world how to do this. And if you combine these 2 things into one step, if you say, write out the gram formula and inspect it, and that's all you did, then that's fine for that step, yeah.
Do you still want the groups to have the official procedure on the white piece of paper?
So, no, not on a white piece of paper. Good question. So, yeah, on the packet. This has evolved, obviously, over the course of the last couple of weeks as to how I wanted to do this. And I'm trying to make it, I want to make it so that the course is a little bit more lab-based rather than just, constantly lecturing. So some of the things that I want to do, I'm trying out for the first time here, and this has kind of evolved over the last few days. So you're helping me to change my course a little bit. But for now, just what we're going to do is create this, and then I'm just going to have you turn your packets in, okay? So I don't really care if you've run out of space and you have to write some of this down below or some of this in the margin. I just want to see that you're all paying enough attention to that we're going to create this procedure together and make it so that the next time you have to do this, I don't have to provide as much guidance. And then the time after that, I don't have to provide as much guidance. And then the time after that, I don't have to provide any guidance. You can just do it by yourselves, right? So this is going to be a progression of activities here. But no, there's no way that if I were to do this again or again or again 4 or 5 more times that I would have exactly the same procedure. It's not written in stone that you have to say something exactly the right way. Okay? So hopefully that makes sense, and hopefully it alleviates any pressure to try and do this precisely and just exactly the way that every scientist would. Oh, actually, I forgot. There's some more spaces down there, isn't there? Okay. So, do we agree, or is there anything else that you think needs to go into this part of the procedure to describe to someone how to find the number of grams when you're going to do an experiment like this? Okay. So, you can get rid of. Okay, so preparing the lead acetate solution, and I said we'd use the volumetric flask for this. So 3, 4, 5, 6, 7, 8. So we're on step 9. And again, you don't need to put circles around this. I'm not sure why I did. So step 9, preparing the solution. What's the first thing I did? Yeah, Aspen.
Take the volumetric flask to the table with the lead acetate.
So you guys are going to have to really speak loud because my ears are plugged and your masks are covering your voices. What now?
Sorry, sir. Take the volumetric flask to the table with lead acetate.
Take it to the table with the lead acetate. Do we want to measure the number of grams of the lead acetate before we do that?
If you measure it before, you would have to carry the lead acetate back.
Oh, I see what you're saying. Okay. So can we put that into one step, though? Can we say measure the amount of lead acetate and take the volumetric flask with you to something like that? Okay. Did you have something to add, Darren?
Tuesday, we got to pass it first.
Okay. Okay. So, taking the volumetric flask to the weigh station. Mass the lead acetate and add to volumetric flask. Okay, so is that kind of what you were trying to say? Okay, so now let me just tell you that if you were to be preparing this for publication, for example, in a medical journal or something like that, or a science journal, when you talk about the procedure, you don't really do it in a step-by-step fashion like this. You do it in more of a text, in more of a paragraph form. You write it out in a more text kind of way. You don't write it out step by step like this, and you would leave a lot of this out, okay? So if you were to be writing this up for publication, you're going to assume that people know how to do that. They know how to take the volumetric flask to the weigh station and add it to the volumetric flask. But here we want this kind of detail. So in a publication, you would probably just say mass the lead acetate using a volumetric flask or something like that, and leave out a lot of this extra detail. So taking the volumetric flask to the weigh station, mass the lead acetate, and add to volumetric flask 10. So what was our technique then to create the solution? What was the first thing we did?
We poured water in about halfway through so we could.
Okay. So partially fill the flask with, okay, and we're going to make a little bit of a change here. We used tap water, and we shouldn't have, okay, because tap water has all kinds of ions in it from, you know, the source of the water. We had chloride ions in it in particular, and that gave us a lead chloride precipitate when we made this, right? It became cloudy. So we're going to say here, partially fill the flask with, and we're going to call this deionized water. Deionized water. In other words, we've taken all the ions out of it. Okay, and actually, Sperry has a water deionizer. It's not currently working right now, so I couldn't get deionized water, but we're going to pretend that we use deionized water. Partially fill the flask with deionized water, and then we said, and dissolve solute by swirling the flask. Okay? By swirling the flask. Partially fill the flask with deionized water, dissolve solute by swirling the flask. If we wanted to, we could say something in here about do not fill into the neck of the flask or something like that. Do not initially fill into the flask neck. Okay? Then what did we do? Got here.
Fill the flask the rest of the way to where the meniscus is just below the desired line.
Okay? Fill flask to where? To where the meniscus is what?
Just below the line.
Okay, so fill flask to where meniscus is just beneath fill line. Okay. Then what did we do? Lucy, what did we do next? So right now we've got, there's the fill line, and our meniscus is right there. How did we fill it the rest of the way? Excellent. Use the correct terms and everything. Use disposable pipette to complete solution to fill line. Oops, yeah. Use disposable pipette. And you could have said that in 1,000 different ways, right? You don't have to use my words. Yeah, Brooklyn.
Did you say like hold it at eye level with like red line?
Yes, okay. If you want to add that detail in there. Hold flask so fill line is at eye level for accuracy. Yes, it would be poor form of me not to include that after I said it so many times, right? Okay. And then, I don't know that I explicitly said this. I know some of you did. Place cap on flask and thoroughly mix solution. I'm pretty sure I don't recall saying to do this when we talked about it, but I did see a couple of you do that. I don't know if you all did or not. But once you get it completely filled, then yes, you would want to put the cap on it and invert it a few times to make sure that it's completely mixed. Okay, so there's no magic to this, is there? It's just list what you did. Try to list it in kind of a sciencey way, you know, but it doesn't have to be language that people don't understand. It's just writing down what you did. Is there anything else that you think we might need in that particular part of the procedure? Okay. Okay, and also I should tell you, although I'm kind of erasing all of my little diagrams here, there's nothing wrong if you want to add additional detail for your audience. There's nothing wrong with drawing little diagrams to help them visualize this either. Okay, so you can create little diagrams if you want to. Preparing the potassium iodide solution, you'll use a graduated pipette and a pipette bulb to add 100 milliliters of water to the solute in an Erlenmeyer flask. And we can kind of use what we've written before. Instead of sitting there and thinking about it, we can kind of use what we've written before and kind of repeat the same thing. Taking the Erlenmeyer flask to the weigh station, mass the potassium iodide, and add to the Erlenmeyer flask. Is what I would do. So, are there objections to that? Do you want to say it a little differently, or take the Erlenmeyer flask to the weigh station, and what do we say? Mass the potassium iodide, and add to Erlenmeyer flask. Now we have to put a little bit of detail into this next part, right? How do we describe the filling of the graduated pipette? Okay, go ahead, Jonathan.
Using 25 milliliter graduated pipette. I don't know what the tool on the top is called.
It's just called a pipette bulb.
Yeah, pipette. With the, let's see, was it 100 milliliters of each? At least 100 milliliters.
Okay. What else do you want to say, Kinsey?
When you first fill the empty Erlenmeyer flask with water,
Well, we're filling the Erlenmeyer flask with the graduated pipette, right? We want it.
No, because you had two, so that you can use the water. You can put the pipette into the water. You have two Erlenmeyer flasks.
Well, one of them was for the filter. The other one was to make the solution.
We had a third flask that was just a whole.
Yeah, it was just a beaker.
Sorry,
Yeah.
beaker, not Erlenmeyer flask.
Okay, so it's okay to assume that you've got a pool of water somewhere that you can. Okay, so that I mean, and I agree with you. I'm making it sound like I've got to write down every little detail, but I will get to a point where that's a detail I think you can probably leave out, because I think people can assume that, well, I've got to get the water from something. Well, but you would be absolutely right in saying, well, some people might not know that you need to put the water in something. So I'll say let's choose to leave that detail out, though. Yeah, Garen.
So using the function of the graduated pipette flows, introduce 100 milliliters of water into the potassium iodide within the Erlenmeyer flask.
Okay, but we want to add some detail to this, because there's some things that you can really mess up using that. And we probably want to add some additional detail. Anybody want to say anything other than Aspen and Garrett and Kinsey and Jonathan? Anyone else want to help me, or Brooklyn? What do you have, Brooklyn?
Just say like using the, what's it called?
The pipette bulb?
Yeah, or no, the whole thing.
Okay, so the graduated pipette.
Using graduated pipette, they drop 25 grams of water 4 times a minute in the Erlenmeyer flask.
Okay, so I want to get a little bit more detail related to how we actually accomplish this. How do I get the 25 milliliters up into? I don't just use the pipette bulb. What am I looking for? Okay, Garen.
Releasing a section from the pipette bulb, bring up 25 milliliters of water through the graduated pipette.
Okay, let's even go more than that. Aspen?
What we could say is attaching it first on the.
Okay, yeah, before I can use it, I need to put it together, right? Okay, so attach a pipette bulb to a 25 milliliter graduated pipette. I can never remember whether it's 2 P's or 2 T's. So attach a pipette bulb to a 25 milliliter graduated pipette. Now you could put a lot of these little steps into the same step if you want. I'm just going to keep adding additional steps here. And I can never remember the letters that are on the bulb. nature. Okay, so the S button here. So the next thing that we need to do is we need to get the air out of here, right? So that we can create the suction in the first place. So we're going to say, I need to do that. Okay, so what would be a word that would describe the expulsion of air from this apparatus?
That. Just
Huh?
that.
What I just said?
But squeeze the
Okay.
two. What
Press.
you said.
Squeeze the main body of the pipette bulb while pressing one of the valves to expel air from the apparatus.
Okay. Excellent. So let's say while pressing the S button,
Would that,
while pressing the S or squeezing the S button, is that what you wanted? Or while pressing the S button of the bulb, squeeze the bulb to expel air from the bulb,
Creating an attraction. Or suction in it.
well, let's just say from the bulb, and then release the S button. Okay?
Mr. Marshall?
Yeah.
Would we also put a description of what it could look like, so it would look like a bowl shape?
I'm sorry, should we do what?
Make a description of what the end product of what we just did looks like, so they know they did it right.
You can, yeah. So the bulb will remain compressed.
I was thinking it would look like a sideways bowl shape.
Look like a what?
A sideways bowl shape.
Okay, or maybe a crushed ping pong ball, or yeah. I would say there's probably a better way to describe it, but we'll go with that for now. I can't think of anything right off the top of my head. The bulb, so the compressed bulb will have the appearance of a bowl on its side. Is that okay? Now that might be a really good spot to have a picture of it or something like that. So I might take a picture of it with my camera and then download it to my computer and then add the picture to the the document that I'm working on, right? Because I'm not going to, if I'm doing this for real, I'm not going to turn this in handwritten. Or if I'm doing this in a lab notebook, though, so I might actually do something like that. Let's just,
You just draw it.
yeah. Okay, you could do something like that. Okay, that's not the best drawing in the world, but I could make that a little bit more accurate. If you wanted, you could even put a little arrow there to say S button. If you wanted, you could even put a little arrow here that says E button. Okay, and these are not things that you have to do or don't have to do, but they are things that you can do to try and make things better for. I think that's a nice little addition, though. That's a good idea. So while pressing the S button of the bulb, squeeze the bulb to expel air from the bulb, and then release the S button. The compressed bulb will have the appearance of a bowl on its side.
Is there the other button to create suction and then the S button to bring in the liquid?
So the S button actually does both does the same thing, right? So I squeezed the S button and then let off of it. And when I squeeze it again, it's going to draw the water back up. Okay? So that leads us to the next step then, right? Okay? So we're going to add, so place the pipette tip. Oops. Pipette tip in so here's where Kenzie's idea might have been a good thing. I'm just going to go ahead and say in the beaker of water and release suction, or I'm sorry, create suction, not release it, right? Create suction by pressing the S button, drawing 25 milliliters of water into the pipette. So do I want to draw 25 milliliters into it, or do I want to actually draw a little more into it?
Yeah, because of the little
Air.
data.
Yeah, drawing, so I should say a little more than 25 milliliters there, so a little more than. Okay, now, well, I'll save that discussion for another day. So a little more than, I forgot my E there. Okay, and then when we got it to a little bit more than 25 milliliters, then we're going to press the E button, right, and let water out of the pipette until there's exactly 25 milliliters, right?
And then repeat 4 times.
What's that?
And then you got to repeat it 4 times.
Yes, then we have to do that. Okay, so using the E button, release suction until exactly 25 milliliters of water remain in the pipette. And I'm going to say, be careful not to jostle the pipette as this may cause loss of water from the pipette. Oops. And I noticed that was a problem. Transfer the water to the Erlenmeyer flask. Yeah. Sorry. Transfer the water to the Erlenmeyer flask using the E button. Repeat. (16 through 19) 3 more times.
Wouldn't it be 2 more times?
3 more.
Oh, yeah.
2 more times.
We specify 3 more times until there's 100.
Yeah. So adding a total of 100 milliliters. Does that work? Okay. And then swirl the flask oops. How did that happen? Swirl the flask to dissolve the solute. Okay. So that's probably the hardest part of the procedure right there, isn't it? Okay. So once you've got the description of how to create the solutions, the rest of it's pretty straightforward. Oops, don't do that. Come on. Okay. Why won't you let me release the footer? Oh, probably because I'm drawing. There you go. Okay. So now we need to create the precipitate. And how do we do that?
Well, it says make sure you got enough paper, so.
Okay?
Not yet, is it? Because that's when she starts filtering
Okay? So obtain a piece of filter paper. Mass it. And record the mass. Okay, now so I probably should have for some of the other things said record the mass of those things too, but we didn't. But just for future reference, usually when you mass something, you record the mass somewhere. Mass it, record the mass. And then we folded the filter paper up, and that's called fluting it. Flute the filter paper. And then what did we do to make it so that it could stick to the side of the... Okay, so moisten it, and place it in the funnel. Okay, now we could have saved that step till after we created the precipitate, right? We needed to mask the filter paper first regardless, but we could have put this step somewhere later, but since we didn't, what's the next thing we need to do then to create the precipitate?
For the solution, for the solution that is currently in the volumetric flask into the Erlenmeyer flask that has other.
Okay? Or we could just use the name of the solution, right? So pour the, which it sounds like some other people are suggesting, pour the lead acetate solution into the potassium iodide solution. So pour the lead acetate solution into the sodium iodide solution. 25.
And then 25 should just be place prepared funnel onto unuser in my glass.
Place prepared funnel into a clean. And we probably should have put the volume of the Erlenmeyer flasks in here. A clean 250 milliliter Erlenmeyer flask. And then do what?
And then filter up.
Carefully filter the precipitate by pouring the solution through the filter. Are there any of the details of that process that we want to include, just to make sure that people know how to do things, or it's okay to do certain things? What was it that we had to do in order to make sure that the filtrate kept going through the,
Empty difficult.
okay?
Once the filtered part is
As, so the stuff that goes through the filter is called the filtrate. As filtrate passes the tip of the funnel, empty the flask to allow filtering to continue. Okay? And we're running out of time here, so let's save this, and we'll finish this when we get back, and we'll talk about a conclusion as well. Are we going through this in thoroughly of enough fashion that you feel like you might be able to do this more on your own the next time we have a lab? Has anyone up to this point in your high school career gone through a procedure like this thoroughly, or is this?
Yeah, great.
Cool. This will do you well in college if you're going to a college chemistry course. Jules.